Hi, welcome back to Key Concepts in Technology. This is the introduction to week 13 on cloud computing and the Internet of Things and ambient computing. Now, for our approach to understanding cloud computing and the Internet of Things, we can call this week Adventures in Massive Modularity, Scalability, and Extensibility, extensions of key Internet design principles that we've been studying. The cloud computing concept and ways of deploying it in actual systems architecture represent further important examples of the cumulative combinatorial modular design principles that the Internet is based on. The extensible, scalable design principles of the Internet and web implemented on a platform of open standards has enabled the expansion of the web into the always-on Internet, the web of active behind-the-scenes network services. The cloud architecture is behind much of the content, software, and real-time data that we experience in our apps, in our web windows, on any IP-enabled device. If you use iTunes, Apple iOS apps, or do Google searches, use Google Apps and Maps, or shop on Amazon or eBay, if you view YouTube videos or use mobile device apps to get real-time data, you are interacting with many layers of behind-the-scenes Internet and web cloud computing network services. The cloud system design essentially bundles many networking, software, and server infrastructure functions into a unified system that goes beyond the limitations of individual servers in one physical location. The cloud design extends the principles for distributed network computing and combining modular network levels that are implicit in Internet architecture, and it scales all this up to even more globally extensible ways. Let's de-black box the cloud, another obscuring metaphor. The cloud architecture is fundamentally a way to use the interactive web platform for all kinds of behind-the-scenes network services and distributed computing resources that can interact with our IP-connected devices and handle massive amounts of data and user connections very quickly. By expanding the range of software processes that can communicate simultaneously, both on our local devices and across the Internet on interacting servers, we're able to design further levels of abstraction for creating virtual computers. That is, software constructs of computation that act like one large massive computer for us end users and for the companies that provision the data and network services that we use. When we interact with data and content on Google, Amazon, Netflix, or social media, it seems like our computer or device is just interacting with another computer server on the network. Actually, what's happening behind the scenes are outputs from many layers of simultaneous network data and software services. And we only see, and only need to see, the end results sent to our devices or PCs. Recall what we learned earlier about the layering principle in network computing. By following an interoperable design that enables what one layer does to take input and pass on its functions to other layers, the cloud architecture allows all the layers of distributed computation to be bundled up and work like unified products or services. In the lingo of cloud computing, we now have evolving industry standards for using the Internet and the web platform to provide software as a service, SaaS, infrastructure as a service, IaaS, and a platform as a service. Let's look at one cloud computing service as an example. Many companies and organizations use Amazon Web Services, now the largest cloud computing business in the world. When we use Netflix, Expedia, Instagram, Adobe Cloud, Spotify, and of course Amazon itself, we are interacting with many layers in the Amazon cloud across the Internet. The physical side of the system involves clusters of interconnected servers and data centers around the world running database software and other software layers for managing user connections and transactions. we see only the user interface level of results as what gets displayed or played on our PCs and mobile devices. The background of cloud architecture is also presupposed in other net and web implementations like the Internet of Things, or as Cisco's now calling it, the Internet of Everything, and ambient computing, a network environment where things with geolocation and sensor chips with wireless IP connectivity can send and receive information and interact with the background of computing processes with or without direct human control. What's called big data, the processing of massive amounts of data from many sources, also uses software in the cloud architecture like Google search engines and cloud apps. So our smartphones, tablets, and PCs act as one kind of a node in the larger cloud, ambient, and Internet of Things design concepts. Our user view of all the outputs from the cloud looks like a seamless, unified integration of results, but from a very complex black box given a mystical, transcendental name, the cloud, which unfortunately attracts all kinds of hype and mystification as well as rants from both dystopian and utopian ideologues. The cloud metaphor has been around a long time in network engineering, and it's actually related to the black box metaphor for encapsulating abstraction layers that don't matter to other levels of systems engineering. In earlier networking, the term cloud was used to bracket off all the complex operations in a system that don't matter to the inputs and outputs used by other modules in a system. And then the term became a catch-all metaphor for a system design that keeps the many interconnected abstraction layers below and beyond what any user, that is a human agent, interacting with software interfaces to use network services, and the end client devices like our individual PCs and IP-enabled devices. All of that hidden from view what any of these devices need to know. So we wrap all the behind-the-scenes technologies in the cloud metaphor because it doesn't matter what networks, systems, or proprietary technologies have to work together to complete our network activity. But metaphors are dangerous. They get reified as things, and then they block off analysis and understanding. As you now know, all the technologies and software layers work not by magic, but because of the organization of the social technical system. Whatever network, server, data, software app, or wireless IP connection we use, all these modules have to conform to strict standards for interoperability and conform to whatever state the industry ecosystem is in for connecting any manufactured component to the whole system. We're concluding our study of Internet and web principles with the cloud and the Internet of Things for an important reason. These recent developments represent a major direction in the extensible future of the Internet, but we're in very early stages of development, and many other combinations of services and functions will certainly follow. The more you understand about these design principles and how they're implemented, the more you'll be able to understand anything that comes next. Well, what is coming next? Everyone wants to know what's the future of the Internet. Well, we'll see more wearable and mobile IP devices. We'll see further build-out of ubiquitous wireless networks for the always-on Internet. We'll see more ways to connect things and places to the Internet. And we'll see more ways of distributing these software processes through the cloud. Now, as we've seen with every phase of computer and Internet technology since the 1980s, we'll also see more competition for consumer markets, corporate rivalries, and bullying by the big companies, standards disputes. We'll see new technologies for miniaturizing components and building IP connectivity into anything, and even more massive modularity. And with all this extensible development, we'll have huge policy debates about Internet infrastructure, about content services, about privacy, about security, how digital data and media will be controlled. And for most consumers and end users, it will all seem like a marketing and PR barrage, of productized black boxes with company brand names and a global shouting match. But you have the tools to do more. Again, we'll see how de-black-boxing the ordinary productized views of technologies empowers us to understand what's going on and provides the keys to participating in the future. The more you learn, the more you'll be able to claim ownership, not as consumers that will just buy whatever is provided, but as an informed participant. Everyone wants the benefits of our technologies with little or no downside. Well, how do we make this possible? We're faced with many policy and information ethics decisions that largely exclude ordinary citizens because they're uninformed and can't claim ownership over these technologies as part of daily life. If the internet and web are to become an always-on ubiquitous utility like water and electricity, then how this extensible web gets implemented affects everyone. By understanding how things work and what it takes for them to work, you'll also be able to envision how new applications can be developed in the areas that you care about. I hope many of our students will go on to become leaders in their fields and professions, empowered with access to knowledge about our technologies that can be used to map out the kinds of futures we want to see.